Dear friends, I am Dr. Jain and this is the last lecture of this unit of electrodynamics, that is flow of energy and Poynting vector. As we know that sound energy are moves in terms of progressive waves and medium is required, and for EM waves they can also travel in vacuum. As we know that energy from sun to earth is only coming by EM waves, so we can say that they can move in vacuum as well as in medium. Now the Poynting vector, that is the last topic, and we can define it, that is relation between energy density and rate of energy transfer, or we can say energy flow per second, that is equal to the Poynting vector. So it is the relation between energy density and rate of energy transfer. So P bar, that is the representation of Poynting vector, that is equal to 1 upon mu 0 E cross B, or P is equal to E cross H. From the third and fourth Maxwell's equation, we have del cross E is equal to minus del B upon del T, and del cross B is mu 0 J plus epsilon naught dE upon dt, or we can write mu 0 sigma E plus mu 0 epsilon 0 del E upon del T, taking dot product with B. So B dot del cross E is equals to minus B dot del B upon del T minus half del B square upon del T square. This we can write like this, and E dot product with B, and now we are taking the dot product with E, the fourth equation. So E dot del cross B is this, we can write mu 0 epsilon 0 E square mu 0 epsilon naught mu 0 sigma E square plus half mu 0 epsilon 0 del E square upon del T square. Subtracting these equations, this equation and this equation, so E dot del cross B minus B dot del cross E, and if we subtract, then these two terms will be come. Now this, if we subtract, then these two terms will come. Now del dot A cross B, we can write B dot del cross A minus A dot del cross B. So del dot B cross E is equals to this term E del cross B minus B dot del cross E, we can write del dot B cross E, and the remaining terms we can write mu 0 del upon del T epsilon 0 E square upon 2 plus B square 2 mu 0 plus mu 0 sigma E square, or del dot 1 upon mu 0, this 1 upon mu 0 we can write in this side. So E cross B is equal to minus del upon del T epsilon naught E square upon 2 plus D square upon 2 this, and plus minus sigma E square. We have converted B cross E into E cross B, so a minus sign will come. Now this half epsilon naught E square will be electrostatic energy per unit volume, and B square upon 2 mu 0 is the magnetostatic energy per unit volume. So energy density will be U equal to half epsilon naught E square, that is electrostatic energy, plus sum of magnetostatic energy half B square upon mu naught. Hence the total energy, if we integrate, then U is equal to U dV, that we can integrate this term over volume integral. So 1 up delta del dot 1 upon mu 0 E cross B dV, this term now we can write here is equal to minus del upon del T, and we can substitute the value, this value here. So by Gauss's divergence theorem, that is volume integral can be converted into surface integral, so we can write del dot 1 upon mu 0 E cross B dV is equal to 1 upon mu 0 E cross B ds. So del dot 1 upon mu 0 E cross B ds is equal to this, we can write like here, and del dot 1 upon mu 0 E cross B ds is equal to this. So this, in this equation, total, this shows total energy flow per second and rate of decrease in energy in E and B fields, and ohmic power dissipated because medium is conducting. The third term is represented like this. Now P is equal to 1 upon mu 0 E cross B, and that is equal to E cross H, that is watt per meter square. So from this del dot E cross B we can write here, and that is 1 upon mu 0, that is the Poynting vector, we can define like this. Now the energy density. For the time varying electric and magnetic field vectors, energy density will be half epsilon naught E square, that is electrostatic energy, and half B square upon mu 0, that is magnetostatic energy. So U is equal to UE plus UM, that is electrostatic plus magnetostatic. So half epsilon naught E square plus B square upon mu 0, but we have B is equal to E by C. So UM is equal to half E square C square mu naught, or that is equal to half E square mu naught epsilon naught upon mu naught. So it will be cancelled out, and it is electrostatic energy. So magnetostatic energy and electrostatic energy both are same. So UE is equal to UM and half epsilon naught E square. So plane EM waves can electrostatic energy equal to magnetostatic energy. So U is equal to half epsilon naught E square plus epsilon E square C square mu naught, or U is equal to epsilon naught E square. Total energy we can write like this, because half magnetostatic energy and both are same. So if we add, then epsilon naught A square. For plane harmonic EM waves, E is equal to E0 sine omega t minus kz, and instantaneous energy density we can write U is equal to epsilon naught A square sine square omega t minus kz joule per meter cube. And average energy U bar, that we can write over a whole cycle 1 upon t, from 0 to capital T we can integrate, and it is epsilon naught A square sine square omega t minus kz, this term. And this we can, so over a cycle U bar is equal to again half epsilon naught A square. Similarly U bar E, that is electrostatic energy, we can have 1 upon T, from again integrate from 0 to T, half epsilon naught A square sine square omega t minus kz dt, and it is equal to 1 upon 4 epsilon naught A square, that is equal to UM bar, that is magnetostatic, average magnetostatic energy. And so this is about the energy density and Poynting vector. This is the last lecture, and now this syllabus is over.